Welcome to part one of lesson three, the Cantillon market model. Richard Cantillon's SI, published around 1730, stands as a remarkably advanced and foundational work in economics, predating Adam Smith's Wealth of Nations by over 40 years, and providing insights that continue to explain market behavior today. Cantillon was the first to systematically analyze economic activity through the lens of individual action, subjective value, and dynamic market processes. Notably, he introduced the term entrepreneur, distinguishing these risk taking agents from wage earners by their essential role in fostering competition, decentralizing markets, and burying uncertainty. This entrepreneurial function involves shrewd decision making amid uncertainty, directly challenging neoclassical models reliant on perfect knowledge and static equilibria, and thereby positioning Cantillon's work as a pioneering and enduring framework for understanding real-world economics. Cantillon's key contributions explored in this lesson include his insight that entrepreneurs face uncertainty by producing at fixed costs, while returns vary with consumer demand. This demand arises from consumer subjective valuations interacting with available goods. Unlike classical economists focused on long-run equilibrium, Cantillon emphasized a dynamic market adjustment, viewing prices and production as constantly responding to supply and demand changes. In his framework, demand shifts can be inferred from inventory trends. Rising inventories indicate weak demand, while falling inventories suggest strong demand. This lesson models Cantillon theories by simulating a market in which an entrepreneur produces a fixed quantity of goods each month. The entrepreneur faces risk from fluctuating prices, which result from shifts in consumer demand. The model features a perfectly inelastic supply curve reflecting the entrepreneur's fixed production commitment, alongside a dynamic demand curve that shifts based on inventory levels to capture subjective consumer valuations. This setup illustrates Cantillon's view of markets as dynamic systems shaped by individual decisions under uncertainty. To understand Cantillon's model of supply, we focus on the bread market in France around 1730. At that time, bread was the most commonly purchased good and the staple of the European diet, especially for the lower classes, often accounting for 50 to 80% of the caloric intake. Because of its central importance, the price of bread, about 80 deniers, a denier is a copper coin, and the bread maker's profit margin, around 8%, were closely monitored due to their political sensitivity. Simile Boulanga is Cantillon's favored bread maker. Suppose Simile bakes an average of 300 loaves per day. Through trial and error, he found that lowering his price by 2% could increase the number of loaves sold by 1%. Using the subjectively derived information, Mr. Boulogne estimates a relationship that predicts the number of loaves he expects to sell on an average day at different prices. Today we call this relationship demand. Using the information above that he deduced while operating his store for years, derive an equation that represents the expected demand for his bread for a typical day. Lowering the price by 2% from 80 deniers results in a new price of what? Well, I'm going to use Desmos over here as a calculator. I have 80 deniers times 1 minus 2%. 2% is just 2 divided by 100, because cent is another word for 100. It results in a new price of 78.4 deniers. I'm going to press enter to make sure I got the answer correct. This results in a decrease in price equal to what? So now I got to subtract 78.4 from 80, and I get 1.6 deniers. I'm not going to type a negative 1.6 because this says decrease. So the change in price is a negative 1.6. The decrease in price is 1.6 deniers. You can drop the negative sign. Now, increasing the number of loaves by 1% from 300 loaves. So we're going to start at 300 loaves, and we're going to multiply that by 1 plus 1%. And we get 303, resulting in an increase in quantity equal to what? Well, I just have to subtract 303 from 300, and it's, 3. So that one's pretty easy. The slope of demand equals the increase in quantity divided by the decrease in price. The increase in quantity is 3. We're going to divide that by the decrease in price, which is 1.6, and I get 1.875. Now, the intercept of demand can be found using this expression. This 1.875, that's the change in quantity divided by the change in price. And the original price is 80 deniers. So the slope is 1.875 loaves per denier. So when I multiply that by 80 deniers cancel. So I'm left with something in terms of loaves. I'm going to add that to 300, the original amount of loaves, and I get 450. Notice when I plug this number in, it fills in my equation here. So what I want to do now is I want to change the equation up here to 450 minus 1.875. I'm going to scale the graph over here so you can see the demand curve. Now, since the demand curve is black here, I'm going to change the color of the demand curve over here by clicking on the gear and then click on the red color and change it to black and then click done. So this demand curve is the same as that demand curve. According to this equation, he expects to sell blank loaves at 78.4 deniers. So I'm going to go ahead and clean this up. I'm going to get rid of all these things here, all this work. I'm going to type in 78.4 deniers per loaf. So I'm going to type in the price. And in this model, P is on the x-axis. Q is on the y-axis. In the past, we've done models where the two have been flipped, but P here is the x-axis. So I'm going to type X equal to 78.4 deniers. I'm going to modify this line, dotted, and the thickness is 1, and the transparency is, I don't know, 0.4. That makes it gray. And you can see this dashed line going up. I'm going to click on it right here, and then you'll see there's a gray dot there. At 78.4 deniers, expected number of loaves sold is 303. Why do I say that? Because when the price is 78.4, expected loaves is 303, that's what we have up here. When the price is 78.4, we have 303 loaves. Let's change the price to 80. So when I change the price to 80, and then I click on this gray dot, I can see at the price of 80, we expect to sell 300 loaves. When I press enter here, the dashed line will shift. This dash line will shift down to 300, and this will shift out to 80. It'll shift to the right. Because this value here corresponds to 78.4 deniers, and this dash line corresponds to 303 loaves. So when I press enter here, now the height of that dash line is exactly at 300, and this dash line has moved to the right just a little bit to 80 deniers per loaf. This equation here is the expected quantity for a given price based on what we have up here. Initially, when each loaf is 80 deniers, we're consuming 300 loaves. So we just verified that this equation represents expected demand. I didn't say demand, I said expected demand. Having baked and sold bread for many years, he doesn't need to perform these calculations because his expectations were formed intuitively, the result of accumulated experience serving customers whose subjective valuations reflect dynamic tastes and preferences. The linear relationship presented here is a simplified expression of those expectations, provided for learning purposes. This kind of intuition is common in business today. People who have produced a good or service for many years often develop an instinctive understanding of their market. In contrast, newcomers to a market typically lack this intuition, but can develop it more quickly by analyzing market data. The quantity of bread that Simile Boulogne supplies each day hinges on expected sales, which are affected by several factors: community mood, weather, day of the week, season, and the health of the broader economy. A seasoned bread maker like Simile, having navigated both prosperous and lean times, develops a sharp intuition for how these variables influence daily demand. Mathematically, these shifts can be modeled as changes in the above demand equation's intercept. For instance, when people are employed and their incomes are rising, the intercept increases in value, reflecting stronger demand. Conversely, due to the prominence of the Catholic Church at the time, Sunday bread demand is weaker than on other days, lowering the intercept's value. These adjustments, while Mr. Boulogne did not have the luxury of computing in an Excel spreadsheet, took shape in his mind, honed through years of experience. Baking too much bread leaves unsold loaves at day's end, which turn stale and lose appeal. As customers crave fresh baked goods, Baking too little, however, means empty shelves and missed sales. This creates uncertainty in deciding how much bread to bake each morning, a challenge that is mitigated through experience and knowledge. In a competitive bread market where bakers operate on a slim, say 8% profit margin, at 80 deniers per loaf, Simile Bonaire, like its peers, has a reservation price of what? We're going to take 8% off the 80 deniers per loaf price. 80 times 1 minus 8% is 73.6. This reservation price is the price they need to get from the customer in order to break even. So they need at least 73.6 deniers. This is the lowest price he can accept as it just covers his cost. If the market price falls below this threshold, he bakes other items. Today, we would say he exited the bread market for the day. Based on the season, community conditions, and his extensive experience, Simile anticipates typical business on Monday. After baking, he expects to sell 300 loaves of bread at 80 deniers each. With a morning inventory of 0 loaves and customers preferring fresh bread, he aims to have 0 inventory at the moment he closes his shop. Thus, he maintains a daily safety stock of 0 loaves. To meet the day's demand, he bakes 300 loaves because he expects to sell that many at 80 deniers per loaf. This quantity is referred to as production. Before opening, he places the freshly baked loaves behind the 0 loaves from the previous day. Consequently, Monday's supply curve is represented as the following horizontal line. So he has 0 in inventory, 300 in production, 0 safety stock, for a total quantity supplied of 300. So this horizontal line, which is a vertical line in demand models where quantity is on the x-axis and P is on the y-axis, this horizontal line here says during this given day, he has supplied 300 loaves of bread at a price of 80. So this is perfectly inelastic supply with the demand curve modeled by this expected quantity of bread demanded for a given price. The quantity supplied is constant as the price increases along the supply curve because, well, prices are not constant. They can rise or fall depending on subjective valuations of consumers. Consumers don't determine supply, the producer does. Entrepreneurs face no risk. So it has to be this one. Supply is fixed at the amount produced prior to opening. He made the decision of how much to produce prior to opening a shop. In this situation, we say that supply is perfectly inelastic. Before Simile opens his bakery early Monday morning, after stocking shelves with the baked loaves, he writes 80 deniers each on the chalkboard above the bread. If the above demand equation reflects Monday's actual demand, then blank loaves will be sold. That would be 300. And 0 loaves are in inventory. And total sales will amount to 300 times 80. 300 sold times a price of 80 deniers. Total sales will amount to 24,000 deniers. Now on Tuesday, in Cantillon's model, demand is determined by consumers' subjective valuations. If Simile senses weakening consumer preferences for bread on Tuesday, mathematically modeled by the intercept of the black demand equation above, so this intercept determines where this line is going to be. If we hold the slope constant, this line will shift down. If this declines, if this increases, this line will shift up. And it could be the case that this line is shifting up and down during a given day. But we're going to hold it constant within the day to make it simple. So if Simile senses weakening consumer preferences for bread on Tuesday, he will anticipate a decline in demand. Now, which of these intercepts is the best choice, given that he anticipates the decline in demand? Well, the intercept yesterday was 450. Decreased demand means that number's got to fall. And your numbers are going to be different than mine, so you got to be really careful here. So which of these numbers is lower than 450? It can't be 450 because that would mean that demand hasn't changed. 460 means strong demand, 470 means even stronger demand, and 480 means the strongest of the demand curves. It has to be 420 in my case. So I'm going to click on 24,000 up there, and then I'm going to press enter to see if these two answers are correct. And when I press enter, this should change from intercept to 420 if I am correct. And I am correct, right? So 420 replaced the word intercept, and notice the demand curve shifted in from black to blue. Supply is still 300 because he is still planning on producing 300 loaves of bread for Tuesday morning. Early Tuesday morning, Sydney Boulogne keeps his posted price at 80 deniers because he notices that other bread makers have not changed the prices they charge. Given that the blue equation above represents his expectation for Tuesday's demand, he anticipates selling what? At 80 bolognese. So let's go up here. We got to modify our Desmos equation here. I'm going to copy this in, create a new demand curve. I'm going to get rid of this and that. I'll pull that down. I'm going to paste in the new equation here. It's green. I want to change the color to blue. The price is still set at 80. And because I have clicked on the price equals 80 deniers, I have two gray dots here. The first is Monday's outcome. The second is Tuesday's outcome. So on Tuesday, he's going to anticipate selling 270 loaves of bread. So if he supplies 300, but he anticipates selling 270, he's going to have a closing inventory of 30. And total sales would reach what? He's selling 270 at a price of 80. His total sales would be 21,600. We're not multiplying the price by how much he supplied, how much he put on his shelves. We're multiplying the 80 by the amount that he expects to sell. So these are his expected sales. 21,600 deniers. Because consumers prefer fresh bread every morning, he wants to sell his last loaf at the moment he closes his shop. To meet the day's demand at 80 deniers per loaf, he bakes how many loaves before opening? Well, he doesn't want to have 30 left over. So he's only going to bake this morning 270. So Tuesday's supply curve is represented as the following horizontal line. He has zero in inventory. He has zero safety stock. And he has a production level of 270. So his supply on Tuesday for any price is 270. He's going to put 270 loaves on his shelves, and he's going to sell them for 80 deniers per loaf. In scenario one, suppose the blue demand equation is Tuesday's actual bread demand, not just as expected. On Tuesday, with his price set at 80, consumers are going to demand 270 when the price is 80. Simulate supplied 270 loaves, leaving 0 loaves in inventory at closing. Lost sales were 0. And total sales, again, is 270 times 80. So total sales is 21,600 deniers, which is this point right here. This height is 270 loaves, and this dashed line is at the price of 80. And so supply crosses demand at that point. That's scenario one. What about scenario two? This blue demand equation is Simile's early Tuesday morning expectation. There's a difference between what we expect demand to be that day and what it ends up being. So if Tuesday's actual bread demand was weaker than what he had expected, this blue line, a weaker demand means the intercept is actually even smaller than what it was up here. So this is what he expects demand to be. It ends up being actually weaker than that. The only choice for this intercept is what? It can't be 420 because that would mean actual demand in the red scenario is equal to what he expected in the blue scenario. So it can't be 420. It can't be more than 420. It has to be less than 420. So this value here has to be, of these choices, the smaller of them. In my case, 390. I'm going to click here and then press enter to make sure I got it right. Demand is actually weaker than it had been. If actual demand had been the same as what he expected in the morning, the demand curve would go through this point, but it was actually weaker than what he anticipated. And that has repercussions. It means he's not selling as much as he expected in that given day. He's going to end up with inventory. So on Tuesday, with his price set at 80, which is this vertical dash line, consumers demanded what? Now I got to come up here and I got to create a new red demand equation for scenario 2. Copy it, and paste it right here. I'm going to change it to red. I'm going to turn off the Monday one. He expected bread demand to be the blue line, but he ended up getting the red demand curve. And at 80, he only sells 240. Quantity demanded ended up being just 240 loaves. He supplied this blue line. Maybe I should put that in there. And because quantity's on the y-axis, I'm going to type y equal to the quantity that he supplied 270. And I'll change that to blue. So if demand ended up being equal to what he had expected when he made his decisions on how much to supply that given day, in this case 270, he would have sold each loaf of bread at 80 deniers. He would have produced 270 loaves of bread, and consumers would have demanded 270. He would have ended up with zero inventory. Instead, with demand being weaker than he expected, at the price 80, which he posted on the store before opening the shop, at the price of 80, he only sells 240, but he supplied 270. So he supplies 270, leaving the difference in inventory. I'll press enter to make sure I got the answers correct so far. And I did. Now, he didn't run out of bread. He just has a bunch of bread left on the shelves. If it was in a situation where his consumer demand was more than the amount he supplied, then we had lost sales. His lost sales here are zero. His total sales is how much were purchased times 80, not how much were supplied times 80. So his total sales are 240 times 80. The quantity that is demanded, the quantity that is actually sold, times 80, the price that was posted. So his total sales reach 19,200. Now, in scenario 3, suppose instead actual demand exceeded Simule's earlier Tuesday morning expectation, the blue demand equation. So let's go back up to the blue demand equation. This is what he expects his demand to be Tuesday morning. If that's actually the case, then if he supplies 270, which he makes before he opens the door, he sells them all at $80. So this is what he expects Tuesday morning. And demand is actually greater than he expected. Then the number that goes into the green equation has to be bigger than 420. And of the choices, there's only one that's bigger than 420. It's 430. When I press enter here, this should be marked correct. This should change to 430. And the green demand graph should lie to the right of the red demand line. So demand is more than what we expected. What we expected is a blue equation passing through this dot. I'm going to add another equation here. I'll change this to green, and I'll change this to 430. And then I'll zoom in. This blue downward sloping line is what he expected Tuesday morning, which is why he made 270 or supplied 270 loaves of bread. But actual demand ended up being greater than what he anticipated. So quantity demand ended up being 280 instead of 270. This is what he expected, and this is what he observed. So on Tuesday, with his price set at 80, because remember when he opened his shop, he noticed that all other bakers had posted a price of 80 deniers. So he kept his price at 80. With his price set at 80, consumers actually demanded 280 loaves. He only supplied 270 because what consumers wanted to buy exceeded what he actually supplied. He has 0 loaves of bread in inventory. At the moment that Simile sells his last loaf of bread, 10 people enter a store looking to buy bread. And those 10 people walk away not buying the bread because 270 people before them had purchased all the bread. He has a pretty good idea that quantity demanded was 280 loaves of bread during that day. So his lost sales are 10 loaves of bread times 80. So he had lost sales of 800 deniers. His total sales, in this situation, he didn't supply enough. The demand was so high that he ran out of bread. So instead of multiplying the price times the quantity demanded, multiply the price times the quantity supplied. So we had to change this to 270. Of everything he supplied, he sold out. So his total sales here are 21,600. In scenario 1, His expected demand is actual demand. This is the model that's presented in all modern economic textbooks. That's not always the case. Sometimes our expectations are wrong. In scenario two, we had a situation where what actually happened is less than what he expected, and we end up with excessive inventory. In scenario three, we end up with a situation where actual demand is greater than what he has expected, and we end up with a stock out and lost sales. For the following, pick the answer you think is best. Check your answer. If you get it marked wrong, don't guess. Come to my office hours. We can discuss it so that you get 100% on these. Richard Cantillon's economic framework and today's neoclassical economics offer distinct perspectives on how markets function, particularly in their treatment of economic agents, price formation, market structure, and demand. Cantillon's economics, articulated in his seminal work, Essai, places entrepreneurs at the heart of economic activity. Unlike the passive agents of neoclassical models, Cantillon's entrepreneurs actively shape markets by responding to price signals and bearing uncertainty. They observe gaps between market prices and the cost of production, cost ultimately rooted in land and labor, and adjust their activities accordingly. When market prices exceed cost, entrepreneurs expand production or enter markets, increasing supply. When prices fall below cost, they scale back or exit, reducing supply. This continual adjustment creates a dynamic market process where prices fluctuate rather than settle at a fixed point. Cantillon's view of markets is grounded in real-world constraints such as land availability, and demand is shaped by the consumption patterns of distinct social classes. His model is descriptive, capturing the fluid, adaptive nature of economic activity as entrepreneurs navigate changing conditions. In contrast, neoclassical economics, which emerged in the late 19th century, constructs a more formalized and static framework. Economic agents in this model are price takers, operating in idealized competitive markets where prices are determined at the market level by the intersection of aggregate supply and demand curves. Consumers maximize utility based on fixed prices and income, while producers minimize cost and maximize profits given those same prices. Once the market establishes an equilibrium price, individuals adjust their consumption and production decisions to optimize their outcomes. This equilibrium-centric approach emphasizes mathematical precision and optimal resource allocation, abstracting away the dynamic adjustment central to Cantillon's vision. Demand in neoclassical economics derives from utility maximization, reflecting subjective preferences expressed through individual choices rather than socially and physically constrained demand in Cantillon's framework. Despite these differences, both Cantillon's economics and neoclassical economics share fundamental principles that underscore their contributions to understanding market dynamics. Both recognize supply and demand as the primary drivers of prices. Though they conceptualize this process differently, in Cantillon's model, supply and demand interact through entrepreneurial actions, leading to ongoing price fluctuations, while neoclassical economics envisions prices converging at an equilibrium point where supply equals demand. Prices in both frameworks serve as critical signals that coordinate economic activity, guiding producers and consumers to allocate resources efficiently. Competitive forces underpin resource allocation, whether through the entrepreneurial responses in the Cantillon model or the market clearing mechanisms of neoclassical theory. Additionally, both approaches acknowledge that demand reflects subjective preferences, though Cantillon ties these to social structures and resource constraints, while neoclassical economics formalizes them through utility functions. Both frameworks also view markets as self-correcting. These shared principles highlight a common intellectual thread, with Cantillon's early insights laying the groundwork for the more formalized neoclassical models that followed. These commonalities are found in the following readings. Read The Entrepreneur as American Hero. As you read this, fill in the answer boxes with the missing words or phrases. And then do the same with From Marxism to the Market.